conversation tonight. So tonight we're joined by Trent Minch, who I met through some employer outreach with his company, eBlue Solutions. And it became quickly apparent that Trent was interested in helping people learn, particularly in the area of QA, quality assurance. And that led to a conversation that is ultimately looking to turn into a QA class that Code Louisville is going to offer in the future, and hopefully Code Kentucky as well. So we're looking to run a whole track or pathway in this stuff. That should show you how important this kind of stuff is, and that there are jobs out there for it. But Trent has a background in QA as a QA lead, architect, worked with several major companies here in the Louisville area, including eBlue Solutions and Waystar. And basically is going to talk to us tonight about a variety of QA related topics, but basically, what is it? What can you do with it? Show you some tools and hopefully some code if the demo gods smile upon us today. And basically, this is a hugely important kind of subset of software development, making sure that it all works well and is all well tested. And definitely seen lots of jobs in it. And in Code Louisville, we've seen a lot of students make a career through QA. Like their first job is in QA, and some of them then switch into software development, or some of them stay in QA their whole career. Certainly been a great entry into the field. So without further ado, I will introduce Trent Minch, and he will be talking to you tonight about software quality engineering.
Thanks, Brian.
Trent.
Yeah, thank you. Happy to be here with you all tonight. As Brian said, my name's Trent Minch. I've been doing this QA thing for about 4 years. So I'm looking forward to chatting about it with you all a little bit, and maybe answering some of your questions at the end. But before we get too far into it, I'll tell you a little bit about me and why you should care about my opinion on QA. So I've been doing it for about 4 years. I started in QA at a company called Dormicaba in Lexington while I was getting my computer science degree there. That company made doors and locks. So my first job was actually doing QA and building automated testing to test physical hardware, like doors and door handles and locks and cool stuff like that. So we built robots and we programmed them, that kind of thing. And that was really interesting and exciting. And then after I graduated, I went on to become a QA engineer in Louisville. So there's a couple of the companies that I've worked at up there, Farm Credit, Waystar, and it's now my privilege to be the QA lead or manager for eBlue Solutions, as Brian mentioned. So I've enjoyed doing QA a lot. QA has offered me personally some great career mobility. It's been a really enjoyable discipline for me to get into from a computer science background, and I'm happy to be sharing a little bit about that with some of you all today. So the first thing that I want to talk about is why QA is important. So Brian mentioned it's a very important discipline in the software engineering field, and I definitely agree with that. We're going to talk a little bit about why that is through a couple of case studies that I find interesting. It's always fun to talk about times where maybe just a little bit more QA could have made a big difference in some sort of software or some sort of big engineering project. So the first one that I want to talk about is Mariner 1 spacecraft. So some of you who are into like NASA and space and their projects like I am might have heard of Mariner 1 before, but it was a satellite. It was built in the 60s and it was supposed to be launched in 1962, operating term supposed to be there. So when Mariner 1 was built, it was the first satellite of its kind, but it was programmed using software that had been used on other satellites in the past. So they kind of ported it over to Mariner 1, even though Mariner 1 wasn't exactly the same as some of those other satellites that code had been used on. They went ahead and ported it over to use it on that spacecraft as well. And so what happened with Mariner 1 was it launched. And very shortly after launching, it veered off course. And the purpose of the software that had the defect in it was to allow the ground control to fix the course of that spacecraft so that it would be back on course. Well, it wasn't responding to their commands because of a software bug. So they actually had to they had to issue an emergency self-destruct, which caused Mariner 1 to explode in midair, costing $166 million in equipment in today's money. So it was a pretty big deal, obviously. Lots of money lost, pretty big consequence for not having great QA. And after they went back and they traced back the original root cause, they found that the change was a single horizontal bar over a letter R to differentiate between the letter R and R bar, which is a term used in some equations. And that error was actually made all the way back in the specifications of the original, what the satellite was supposed to do. So would have been an opportunity to catch that problem if we had done testing, certainly, but even if we had just combed through the requirements for that spacecraft a little bit more carefully, we might have caught that. A lot of people refer to the Mariner 1 incident as the reason why software QA exists as a discipline today in the way that it does, because it was the first time that we realized that super small, super simple software bugs like that could have such a big impact. So I'm always fascinated by that case. So let's talk about another one. 2003, St. Mary's Medical Center was a hospital, and they were upgrading some of their internal software. They had some software that they were using to track patients ingoing and outgoing, and they were going to upgrade it to a new version. Very common use case, very common thing that happens in software. So they did that update, and when they did so, they had to map their existing patient records into the new system, into the new format that system was using. And when they did so, they mistakenly mapped a status of discharge to a deceased. Now, this mistake was made by the developers of the software. It was made, the software was built custom for this hospital, and the developers did not recognize the difference in their testing between what the software was supposed to do for this company and their existing platform. So they mismapped that status of discharge to deceased. And when they did that, as soon as the new software went live, over 5,800 patients were marked dead. They were considered dead. And it was a big deal because this new software, it was so fancy that not only was that status marked internally in their software, it was also blasted out to insurance companies and Social Security. So on the insurance company and Social Security side, they also received notification incorrectly that had happened. So they estimated that there were millions of dollars of damage caused by that. But I think that's another good example, maybe a little sillier of a time where software QA might have come in handy for that company. Another one, Heathrow Terminal 5 in 2008, they wanted to upgrade their baggage tracking system. They wanted to go from the baggage tracking system that they had to something new that was supposed to be more optimal, was supposed to be more efficient, but they were smart and they did not immediately implement the new system across all of their terminals at that international airport. They just implemented it at one, terminal number 5, dry run, see how it went. Test it out. And turns out even that wasn't good enough because when that software had been tested, it had not been tested under a realistic load for what the software was supposed to handle. They had been testing sample sizes of a couple hundred pieces of luggage, but in actuality, the software needed to support several thousand. So when they went live, it was totally overwhelmed by the volume of baggage that it needed to process to the point that it just quit working entirely. And as a result of that, thousands of bags were sent on airplanes to the wrong place. Hundreds of flights were delayed, and Heathrow was on the hook for $50 million worth of damages that they had to pay back to airlines as a result of the delays. So big one, as you can hear, the numbers are getting pretty big with some of these bugs. But none quite as big as Knight Capital Group. So this is my favorite case study on this list. It's also the most recent one. So Knight Capital Group in 2012, they were the largest trader in US equities. Enormous company, absolutely massive trading company. So massive were they that they thought they would use some of their wealth to invest in a new trading software that was supposed to be state of the art. It was going to use the online stock exchange to calculate the best possible trades. It was going to place them. It was going to handle everything automatic. They thought that this was going to print money for them. They were super excited about it, invested very, very, very heavily in its research and development and the algorithms that went into, but unfortunately not so heavy into QA testing. So what happened was when they went live with the new software, it immediately purchased $7 billion worth of stocks due to some error. And believe it or not, Knight Capital Group, they didn't have $7 billion on hand in 2012. So they were in a bit of trouble as a result of that. So they canceled as many of those trades as they could, but they were still on the hook. They were unable to cancel $440 million worth of those trades, which not only ate up all their liquid capital, but ended up not making any money anyway. And so just a few months later, less than a year later, Knight Capital was acquired by another investing group at a tenth of the value that they had originally been valued at just a year earlier. So a bit of a mistake on their part, not thoroughly enough was the testing on that new software. So there's a couple of good examples there of why we have software quality as a discipline. Why do people do it? So let's talk about now, let's talk a little bit about what software engineers actually do. So the obvious thing is they are software quality engineers as a discipline. The goal is to prevent situations like those that we just talked about from happening, right? That's the idea. It's to ensure the quality of some piece of software. Does it do what it's supposed to do? Does it do only what it's supposed to do? Is it free of defects and free of bugs? That's kind of the whole idea. And we'll talk a lot more later about the difference between how we do that from a software quality engineer perspective, as opposed to a software engineer perspective, like a web developer that you might think of. So how does software QAs do what they do? Well, it's a multi-step process. And there's a lot of different stuff that kind of goes into it. But the first thing that they do is software quality engineers are involved at testing from the earliest stages. So testing includes testing of project requirements. So we talked about back in the Mariner 1 example, how the mistake that was made that caused that satellite to ultimately have to self-destruct was actually in the requirements themselves, right? They did not thoroughly analyze their requirements enough in order to make sure that the software they were writing for that spacecraft was correct. And as a result, it got coded that way. It wasn't caught during testing and it had to be destroyed. So one of the quality engineer's most important jobs actually starts before any code is even written. It's in looking at requirements and understanding what a piece of software is supposed to do and looking for any opportunity for mistakes or defects to come out of that. Once that's done, software quality engineers are responsible for helping developers write testable code. So Brian mentioned that there's a Code Louisville class coming up, and one of the things that a student in that class would learn is, even if not necessarily how to write the code itself, how to write it in a testable way so that we can check to see if it's working before a user starts getting access to it. And then we test, right? Once code is written, we test. We go through manual test exercises. Modern applications are usually web applications. That's the trend right now. So we open up our web browsers, we go to websites, we test applications by looking at them, by clicking around, by thinking critically about how they work and how they're supposed to work, by thinking outside the box about things that maybe hadn't been considered in the design. And we try to figure out how it works. And if it can break, we try to figure out how to make it break. And then critically, for a software quality engineer, the biggest thing that sets this type of quality engineering apart from other types of QA engineering, like a quality assurance analyst role or something along those lines, is the creation of automated tests. So almost everything that we do as software quality engineers can be done in an automated fashion. And by and large, if you can automate something, it's often a good idea to do so. So creating automated tests is an important part of the software quality engineer's repertoire. It's part of their arsenal to help do their jobs efficiently and effectively. Humans are prone to mistakes. Computers make fewer mistakes, but they still make some, which is why the discipline exists, right? Okay, so we've talked about, you've probably heard about how software development works. I assume if you're coming to Code Louisville talks, you probably know a thing or two about software development. As a result, you probably have heard of this thing called the SDLC, or Software Development Lifecycle. So that's the process by which software is built, right? We gather requirements, we analyze them, some sort of design takes place, we write some code, we test it, we deploy it. That's the SDLC in the simplest terms. But what you might not have heard of, even if you have heard of the SDLC, is there's also this concept of an STLC, the software testing lifecycle. And you might be tempted to think, if you look at the SDLC, you might be tempted to think that most of what we do in the STLC happens in this testing section of the SDLC. And there's legitimacy to that. A lot of what we do does happen during that phase, but not everything, right? So we talked before about how important it is for quality engineers to understand requirements. So at the same time as developers and product owners are gathering and analyzing requirements, testers, quality engineers are also analyzing those requirements, and they're beginning to think from that early of a stage about how they might test something, how they might ensure its quality later on. So by the time development begins, test engineers are already designing tests. Maybe there's some sort of setup required that we have to be aware of. Maybe there are data factors that we need to consider. We talked about a system that failed earlier due to an unexpectedly high load. So how much of a load does our system need to be able to withstand? We're thinking about these things before coding even begins and into the development phase of the SDLC. And then once the code is ready, we test in as incremental of pieces as possible, right? As soon as some piece of code is functional and ready, even if it's not the full system, we begin testing right away because the sooner you catch a defect, the cheaper it is to fix. So that's kind of where QA, I guess, fits in to the whole picture. So what do you need to know how to do to be able to be a software quality engineer? So there are some skills that you need. You have to have what makes the software quality engineering role unique amongst some engineering disciplines, especially software engineering disciplines, is that you have to have two separate but related skill sets kind of on lock. You have to have development skills and also testing skills, right? You can be the best tester in the world, but if you don't have development skills, there are a very large number of companies that will not be as interested in hiring you for your testing skills alone because they value, like we talked about, we value that automation skill set. We value the understanding of code at a deep enough level to know how to write it in a testable way. So you have to have both of those sets of skills. Your testing skills are generally going to revolve around requirement analysis and understanding how to test something yourself in an exploratory fashion and identify defects, right? It's important to understand what parts of some system are critical and essential to end users, what parts they need the most, what parts are most important to them. But it's also important as a quality engineer to understand the sort of edge case scenarios, the parts of the system that are only going to be used by a couple of people, but might have the biggest impact were there to be a defect. So testing skills are useful for identifying those different kinds of cases. But you also got to have development skills. Software quality engineers have development skills on par with software development engineers. And I think maybe the critical thing to mention is that software quality engineering is just a specialization of programming, just like web development or database development. It's just a different specialization than those other fields within programming. And so you got to have those programming skills as well in order to be a successful software quality engineer. Okay, so that's a lot about the discipline. Let's talk a little bit about how some of the big companies in the tech space do this software quality engineering. So let's talk about Google. So Google has transformed the way they do quality as their company has grown. A long time ago, whenever Google was first starting out, they did not hire dedicated testers. There was very little dedicated testing going on, and what was going on was largely done manually, often by the developer who created the code in the first place. They've gone through some transitioning. There's a great book you can read called How Google Tests Software that talks about some of those transitions. But now, as I understand it, largely what Google does is they hire one type of QA or quality professional that they call a test engineer. And the test engineer's primary purpose is to create automated tests. So it's interesting to think about how Google went from a place where they had almost no testing, and what testing was done by developers, to a place where they had lots of testers, right? In that middle point, they had lots of testers, lots of manual testers, lots of software quality engineers, lots of people in between. And now they're kind of tilting back the other way, where they don't have as many manual testers anymore. And most of their testing is done by software engineers who have a testing specialization. And the reason for that is because of how good they have been at keeping their automated coverage high, right? So they've taken this process that used to be not done at all and then was done very manually, and they're now doing it in a very automated way, to the point that they don't really hire manual only QAs anymore. The manual only QA discipline is sort of fading away at Google and in lots of other large companies. Another good example of that being Amazon. So Amazon call the role QA engineer. That's what they call it internally. And the QA engineers at Amazon are required to have excellent programming skills. In fact, the technical interview to be a QA engineer at Amazon is the same interview as if you wanted to be a development engineer, because they understand that the skill sets are largely the same, just with different specializations. So very challenging programming questions on their interview, implying that they understand that you have to be a capable software developer with a specialization in testing in order to succeed at being a test engineer. And just like Google, they don't have manual only QA positions, right? If you want to be a test engineer at Amazon, you have to be capable of creating test automation. Also, something interesting that I should note about these two companies is Google and Amazon and some of the other really big tech companies like Microsoft, Facebook, Apple, they were sort of among the first companies to understand this about software quality engineering, in that it is an equivalent discipline to like web development, and to actually start paying those employees on the same scales. So the track for advancement as a test engineer at Google, for example, your opportunities for promotions, your opportunities for raises are going to be the same regardless of whether you're in test engineering or web development. They're considered equal disciplines, which I think for folks who have experience in QA at smaller companies might sound sort of like a foreign concept, but because they understand that the skill sets are basically the same, they understand that the pay scales and promotion scales ought to be the same as well, and they do that. So let's talk about, so not every company obviously is like a massive, gigantic corporate tech company. Not every company is Facebook, Amazon, Google, Netflix, Apple, Microsoft. Like there are other companies that hire QA engineers. In fact, I think if you go search like quality engineer on LinkedIn right now, you'll find like 15,000 job listings. They can't all be Facebook and Apple, right? So how do some of the other companies do it? Well, I can't speak for every company because I haven't worked for every company, but I've been around and I've talked to some people. And my understanding is that lots of companies right now in this space that hire QA engineers are in kind of this space between where Google was 10, 15 years ago and where these big tech companies are now. They're in that space where they have some QA going on. They have processes. They understand that QA is an important discipline. They understand that quality engineers help drive the success of a product, but they're not quite as mature as maybe some of the big companies are. And usually where that maturity is lacking is in their automation solutions. So their automation is their biggest area for growth. It's their biggest potential to improve their QA standing as a whole. And as a result of that, they prioritize hiring automation capable candidates. Now, this is true at almost every company, almost every software company, almost every company that does something that produces code. They're going to prioritize hiring automation capable candidates because they see, just like we've talked about, they see where these big, super successful companies are, and they want to get there. And they know that the path to get there is by hiring QAs with development skills, is by focusing on automation. So even they hire relatively few manual only QAs, which is why having that diversification of skill set is so important. Okay. So yeah, so like I said, I haven't worked everywhere. That's just sort of the trend that I've noticed. It's very valuable to have that that diversification in skills. And to that point, like Brian said earlier, Code Louisville is going to be starting up a QA course later in the year. So we'll talk a little bit about what's going on with that. It starts in the September session, I believe. And Brian, you can correct me if I have any of the details wrong here. But the point of the course will be to teach you what you would need to know in order to be successful as a software quality engineer, not a manual only tester, not a specialization in web development, but this quality engineering angle that would really set you up to be successful. So we want to teach you the skills that would make you or get you on your way to being competitive at the Amazons and the Googles. So that way, if you walk into a startup or a smaller company, you're going to look great in their interviews and you're going to rock it. And if you're already in a position where maybe you're a manual focused QA, or maybe you've got a little bit of programming skills, but you really want to advance that into something specialized, then this course is going to have that for you. So you're going to get both sets of skills, the programming ones and the testing ones. So if that sounds good to you, then that will be starting up in September. If after hearing what we've talked about a little bit, you still need a little bit of convincing as to why you might want to take a class like that, boy, do I have a chart for you. So we talked about how lots of folks go out of Code Louisville into QA. And a reason for that is that the position is extremely in demand. The position is, there's tons of listings, lots of remote available positions, just like with lots of development or software jobs. People are hungry for folks who have this skill set, especially with the automation and the testing skills combined. It's a rare skill set to find. People want it really bad, and they're willing to pay top dollar for it. So the charts on here are showing you what you could stand to earn as a quality engineer or a test automation engineer, and it's competitive. So if you had your doubts, definitely the positions are out there. They are hiring, and they want folks who have that automation skill set. Beyond that, maybe you think, well, there's little difference between that and a web developer, and we can talk a little bit about that comparison later on. But one thing that appeals to lots of folks, especially starting out, is that the quality engineer position, the on the job, the day-to-day, has much more of a balance between technical skills, technical requirements, and less technical skills and requirements. So at the end of the day, you're still doing a software job, right? So there's going to be some technical requirements there. But if spending 80 to 100% of your day, every day, writing code sounds a little exhausting to you, and you think maybe you might like to spend some time doing things like requirement analysis, having conversations with stakeholders, interacting with your end users to understand what they expect from your software and what they would consider to be quality. Maybe this position might appeal to you a little bit more if that's something that sounds good to you. Okay, so what do you need? What's going to be on the course? So let's talk about what you're going to learn. So we talked about you got to have coding skills and you got to have testing skills in order to be a successful QA. And this course aims to teach you both. And we're going to do them at the same time. So it will not be like you learn all of your programming and then you learn all of your testing. You're going to do them together over time so that you can take each one slowly instead of trying to rush through the first one and then rush through the second one. So we're going to do them together. So the coding skills, it'll be in C#. The availability of material for us to teach from is very, very high in C#. C# also popular in Louisville. So if you're in the Louisville area, if you're a Code Louisville person, then that skill set will be super relevant to you around here if you wanted to get a local job. But also C#, one of the most popular programming languages in the world. So you wouldn't have trouble getting like a remote position either if that was your background. And if you can learn one programming language, you could certainly learn another one as well. So we'll be doing it in C#. Once you've got those basics of C# down, we'll be doing a fundamentals course. There'll be mentors involved to help teach with that kind of stuff. We're going to talk about how to write testable code, right? So we said earlier on, that's a skill that quality engineers have, is how to write the code in a testable way. That sounds really abstract whenever you say it, because it sounds like it would be easy to say, well, all code is testable, right? And so writing that testable code is going to be something that's on the track. Then we're going to teach you how to write unit tests. And a unit test is a type of automated test that is run against the code itself. And it's a critical skill for developers to have, but it's also a very useful skill for quality engineers to have because it serves as the foundation for the more advanced automated tests that you'll learn later on. So eventually, by the time you get to the end of the course, you'll be learning how to do some fully automated tests against web applications. So we're going to set you up to not only understand what needs to be tested from the testing side, but also to automate that from the programming side. So you'll learn all that. You'll also learn testing skills. So basics of testing, you're going to learn the terminology. You're going to learn what you need to know as a tester in order to be successful. Requirement analysis testing. So we talked about how important it is to start your testing from the earliest phase. Test techniques. So that's going to be stuff like load testing, performance testing, security testing, accessibility testing. We're going to make sure that you are equipped to ensure that your application is quality from all perspectives, not just does it do what it's supposed to do, but is it going to be friendly to colorblind users, those kinds of things. And then test tools. There are lots and lots and lots of different test tools out there. Lots of different companies use lots of different technologies and programs and bot solutions to do things in the test space, but we're going to focus on just a few of the most common ones. We're going to teach you how to use your IDE to write code. We're going to teach you how to use dev tools in Google Chrome, which is a critical tool for testing web applications. We're going to teach you about Postman and how to use it for API testing. So those things will be in there as well. And during class, we'll be talking a lot about soft skills. Soft skills are critical to being QA. They're critical to being a quality engineer. It's important to understand the relationship between the quality engineer and the web developer and how to navigate that from a soft skill perspective. As a quality engineer, you might work at a company that doesn't have perfectly established quality principles. So how do you champion for that? How do you get those put into place at a company that maybe doesn't have an existing QA backbone or framework or process? So we'll teach you how to communicate those effectively, how to show the worth, and then how to do it as well. So that's what's going to be in the course. So a couple comparisons between some existing roles and the quality engineer. So what is the difference between the positions? There's software quality engineer, and then there's the software engineer. So we talked a little bit before about how the quality engineer typically, not always, does a little bit less coding day to day than a software engineer or a developer would. 40 to 60% is my estimate for about how much time I spend coding in my day to day, whereas most developers spend most of their time writing code or in meetings, so 80 to 100% for a software engineer. So if it seems a little bit more approachable to you to spend less time in that, software quality might be for you. Obviously, the quality engineer is primarily responsible for testing an application for ensuring its quality, whereas a software engineer or developer is primarily responsible for building it. And the quality engineer also gets to be involved in all phases of the development process, everything from when requirements are first drawn up all the way through to the end, whenever we're delivering to the end user and ensuring that their needs are met. You get to be a part of that whole thing. So if you're the kind of person who likes to see things through, who likes to see things end to end and not just have kind of a window into what's going on from one perspective, quality engineering has that for sure. Whereas development a little bit more focused on just the code writing part of the SDLC. So I also want to make a distinction between software quality engineer and QA analyst. So software quality engineer is the more technical role. Now you'll hear these terms used interchangeably. Sometimes at some companies, sometimes you hear QA engineer or QA analyst or test automation engineer or SDET, software development engineer in test, which really hones in or really focuses on the development aspect of the role. But there's differences there. So as a quality engineer in today's job market, you're doing some coding, whereas a QA analyst might not. You're going to be creating automation, whereas a QA analyst is mostly going to do manual work. But critically, as a quality engineer who understands automation, you're going to have career mobility. If you want to transition, like Brian said, into being a developer, you can do that because you're going to have the foundational programming skills necessary. If you want to transition into management, well, you can do that too, because you're going to have experience with a whole process, end to end, beginning to end. You're going to understand what it takes to see things through more so than if you just had a single window into it. Now, that's not to say that developers and QA analysts don't have career mobility. They certainly do. But as a QA analyst, your best opportunity for career mobility is usually going to be learn some programming skills and learn how to automate. And that's how you develop, right? I imagine that if there are QA analysts on this call that don't have automation skills yet or haven't learned a lot of programming, probably the number one thing you would hear from your manager would be to learn that skill set, because that would be the way to develop and advance out of that position. So automation is the key, and that is why we will spend a considerable portion of our class learning how to do it. And okay, that was my espousing about the role, about the position, about the course, and about what's going to be in it. So let's look a little bit now. I have a slide for this, I think. Yeah, let's look a little bit now at what we do from QA. So I have a website here. Hopefully when I pull this up, everyone will be able to see. This is my website. This is my bookstore website. It is definitely not just a demo website. It's totally a demo website. But the purpose of this website is to be a bookstore. It's actually for practice. We might use this website in the course to do our projects. And this website has a login page. Turns out lots of websites have login pages. Maybe on this book website, they want you to log in so that you can track what books you want or what books you have and have read. I don't know, but it has a login page for one reason or another. And as a QA, it's going to be our job to test it. So in my course, I'm going to learn things like how to test this username and password input for security. I'm going to learn how to test it for the happy path, correctly logging in pathway. I'm going to learn why this looks like this. It seems like there's supposed to be a picture here, but there's not. There's just a text that says Catalan Academy. Maybe that's a bug that they put in there for me to find in my QA practice. I don't know, but I'm going to learn whether or not that's supposed to be there and how to tell in my QA course. I'm going to learn how to open up this thing over here that you might have opened by accident before, or maybe if you're a developer, you've seen it a lot. And I'm going to learn what everything in these tabs actually means and how to use it to do my job as a QA effectively. So I'm going to learn how to test. Those are the things I'm going to learn how to do. And I'm also going to learn how to test this, this application, this login page, 20 times in 3 minutes. 3 minutes, that's probably optimistic. 20 times in like 45 seconds. And I'm going to do so via automation, and it's going to look like this. I don't know how this is going to look for you all, but we're going to maybe see what some automated testing looks like up on the screen here briefly. Yeah, some of the windows are getting a little cut off, but it looks like it's coming through. So behold, blink and you missed it. But if you were paying close attention, you might have noticed that we just tested this website 20 times in, it says 37 seconds on my other screen. So test automation, that's what it's about. Did you understand what happened? No, probably not. Did I? Not so much either, but it did. We did some tests, and we have the code here, which I'm not going to walk you through. If you want to understand what all the code that it took to make that happen is doing and how to write it for yourself, then you're more than welcome to sign up for the course. But just know that I tested that application 20 times in what I say, 37 seconds. Yeah, something like that. It took me about 45 minutes to write all the code necessary to be able to do that. And it will continue to work forever, right? I have access to that as a resource now. I never have to manually test what I just wrote that automation to cover again, because I have that coverage, right? So the payoff on that is huge. The efficiency was great. We saw how fast it was. And that's why test automation is such a big deal in the industry as a whole. Okay, let me put that back up there for you. All right, so about 40 minutes in, and I think I'm gonna stop there. That was the end of my demo, and I'm gonna open it up for questions from you all, if you have any about QA as a discipline, about my career path, about testing, test automation, about what it's like in the industry, about the course. I don't know too much about the Code Louisville's logistics side, but Brian is here to answer those kinds of questions if you have them, anything that you all would like to ask.
I'll go first.
Sure.
Yeah.
So I am in QA and I'm a little bit new to it. And we were just talking today, actually, on my team, if there were any like conferences or trainings that we could continue our learning. I was wondering if you knew of any of those resources, and free is always better, but since this will be through my work, they said that they would pay for some of them too. So paid is okay too.
Yeah, for sure. Well, locally, Codepalooza comes to mind. So Codepalooza is not a QA focused conference, but there are usually QA talks. In years past, when I've gone as a QA, I have been able to fill my schedule with just enough QA talks that I maybe had like 1 or 2 open slots to go just hear about something I was interested in the development space that was different. But I think usually there are like 8 to 12. Like you have time to go to 8 to 12 sessions or something like that at Codepalooza, and you could probably fill 6 to 10 of those with QA talks if you were interested. I do think Codepalooza is paid. I'm not sure how much it is. In fact, I'm certain that it's paid, but I'm not sure how much it is. But you could check that out if you're in the Louisville area.
I'll quickly throw in a plug for Codepalooza that they take volunteers, and you will see an announcement through the Code Louisville Slack and through the Code Louisville Slack about it. And if you volunteer for a day with them, then you get a free pass to it. So yeah.
Cool. Yeah. So that one's good. So that's local. There are a couple of QA conventions that I know were going on prior to COVID, but honestly, since COVID, I don't know so much anymore. I'm trying to think of the name. I know that there was a QA conference East that used to happen once a year. On the East Coast, on some East Coast city, not the same city every year, I don't believe. And then there was also a QA West version of the same conference. And the name is escaping me at the moment of what it was called. But I know that they happened and that they were once a year. Just can't quite remember the name. I have not been, but the last year that I remember looking at the course schedule, it looked really good. Microsoft and Google will also each occasionally hold talks about QA. Microsoft less so in recent years. But if you're looking for something like that for more information, you could subscribe to their Twitters. They will tweet about things like that, about when they are coming up if you're a Twitter person. Yeah, those are kind of the ones that stand out to me conference wise. There's lots of other resources online that you can check out for sure. In particular, Google has a testing blog that they update pretty regularly, as does Atlassian, the makers of Jira. If you're familiar with Jira, they have great resources online about how testing is done in 2022, as opposed to lots of resources that you can find that maybe are a little bit more dated. Good question. Thank you.
Yeah, thank you so much. That was really helpful.
Yeah.
Any other questions anybody has? Real quick, just because there are some questions in chat, I'll address it out loud. But as far as signups and stuff go, we haven't finalized a lot of the details of that. Certainly our preference, speaking as just program administrators, would be that you finish whatever pathway you're in before exploring another one. And there are some questions we need to still answer internally with this class about like priority if the class fills up or overfills, who gets priority first and stuff like that. But that being said, if this class does interest you for the Code Louisville folks in September, just reach out to Rakai or Emily, and they can field questions or get you signed up for it once signups are going on. Code Kentucky folks, we don't have plans yet to offer the class, but we're talking internally about what do we want to offer next year, and I think this is going to be on the list for those out in Eastern and Northern Kentucky. But yeah, any other questions for Trent or about QA?
I have another question if no one else does. I was going to let someone else go. I am curious, this is something that I've run into, and since you did a demonstration with username and password, what's your preferred method when automating tests of like keeping passwords out, like from being hard coded into your tests?
Yeah, it's tricky with credentials, right? Because they can't always be changed. But there's a couple of things that you can do. Lots of companies will implement as part of their production application a secure vault that you can store things like credentials in. That'll let you keep track of those things, and you can then request access to those credentials via an API call that is also secure. So you can store your credentials in a secure vault, and then you can request them at test time, usually just once, and then store them in local memory for your tests, and then you'll have access to them throughout your suite. Which is probably the preferred way to do it. It's probably the correct way to do it. Generally speaking, checking your credentials into like source control is a little suspicious, especially like obviously you would never do that if you're working on an open source project with a public GitHub repo or something like that. So you wouldn't want to do that. So secure vault is a good way to do it. The other thing that you could do is you could talk to your developers and you could ask them to essentially build you in a backdoor that works in your lower environments only. Obviously, you don't want sneaky little testing backdoors in your production application, but it is possible to create them from the development side that allows certain users in, maybe based off some cookie that they have that you would only you would know about, or something else configured about their browser so that they know who you are to let you in. If your system leverages SSO to sign in, lots of SSO providers give you a way to get in as a test user via some backdoor. So it just kind of depends on what your system is doing. But probably the secure vault thing is the best thing to do. Of course, if your code is stored securely, so if you're not in a public GitHub repo or something like that, if you're hosting your code securely in a way that the outside users wouldn't have access to it, it's not the worst thing ever to have credentials stored in there. It's considered a big no-no because it's an opportunity for leakage. But if your test accounts are configured correctly, they shouldn't have access to your production instance of your application. And they also shouldn't have really all that much power to begin with, no more than they need to log in. So that's how I would probably go about it. The main way that I've seen it done at companies that I've worked at is via the secure resource vault, the secure vault that you have to interact with via API. But I'm certainly not going to act like I've never seen or worked in systems where it was just in a config file that was hidden in some private repository.
Yeah, awesome. That's kind of what I was looking at, was the vault, but I came across several other suggestions. And so I was just curious what you had seen, since you've got a lot more experience.
Yeah, sure. Absolutely. Yeah, thank you.
Yeah, I'll probably be on the run. Yeah.
Maureen, did you have a question?
Oh, so sorry. No, my deepest apologies.
No worries. I have a question for you, Trent.
Sure.
Is there a particular bug or error that you encountered or that you have repeatedly encountered that makes you just stop and go, ugh, I see that all the time. Like, how could they miss that? Or something that newer developers always make the same mistake on or something like that?
Yeah, there are. So one of the biggest things that I notice, even in like applications that exist that are like in production that I have used as a user, is whenever you click on a link to go somewhere and the link that you click on has like an ampersand in the text that's not been properly turned into Unicode. It's not been properly URL encoded. So you click on the link and it takes you to a 404 page. And lots of people have like, they'll have like a custom 404 page on their website that's like, oops, this page doesn't exist. And the problem isn't that the page doesn't exist. The problem is that you sent me to the wrong spot because you didn't URL encode your ampersand. So I see that one a lot. You can also, so we talked about like Chrome DevTools and how you would learn how to use it in the course. You would be amazed at the things that companies with their professional websites put out on the client side, which is the stuff that you can see through DevTools. You'd be amazed at what they put in their client side code. One example that stands out to me is like, have you ever been on like a Hotwire or Travelocity or some travel website or whatever, and they'll have on there that like 21 people are looking at this deal, act now, or whatever, like something to try to encourage you to buy. Well, if you inspect element on those, a lot of times they'll put the logic on the client side for how that number is calculated. And it's usually just a random number between like 15 and 40. And I've seen that on travel websites, which I think is hilarious. So yeah, those are some fun ones. So just poking around. There was something in the news not too long ago about how some hacker used Chrome DevTools, used inspect element, which is something that everyone has access to gain unauthorized access to some system and leak a bunch of passwords. Like the power of it and the simplicity that it is to avoid that is just funny to me. So yeah, that kind of stuff, I guess. Yeah, simple stuff.
I believe every one of those. All right, last question. Last call for questions.
I just thought of another one when you talked about hackers. I love the podcast Darknet Diaries. Do you have any like testing podcasts that you would recommend?
I'm not familiar with any, actually. There are a couple of YouTube channels that I subscribe to, but I don't know about podcasts necessarily.
YouTube channels works too. Anything that you you like to watch or listen to regularly.
I'm trying to remember what the name of the channel is. I'll post it in the chat whenever I find it. I don't have it bookmarked, but yeah, there's a couple of YouTube channels out there that produce content about like how testing is done currently, which is great because there's a lot of content out there about how it used to be done, and in software things change really quickly. So having that like up-to-date information is really good. Yeah, QA at the Point is the one that I'm thinking of, is a YouTube channel that has really good like current stuff. So I'll post a link about that here in the chat. Yeah.
Thank you.
All righty. Well, Trent, thank you so much for taking the time tonight to tell us more about QA. For those in Code Louisville Slack, he is on Slack there, and you're welcome to reach out to him. And for those in Code Kentucky, if you want to get in touch with them, just reach out to me and I can connect you all. So yeah, again, thank you, Trent. It was a fantastic talk, and look forward to seeing this class in the future.
Thank you all. I appreciate it.
Thanks, everyone. Have a good night.